In this section, we're going to talk about trigonometric functions. Now, just to highlight a couple things, this is true of all triangles. All three angles add up to 180 degrees. For right triangles, we know one angle is 90 degrees, so the other two have to add to 90 degrees, making them complementary angles. Now, what's also true about right triangles is we have the Pythagorean theorem that this side squared plus this side squared equals the hypotenuse squared, or what a squared plus b squared equals c squared. What it's really a leg, this is called the leg that makes up the 90 degrees, so it's a leg squared plus a leg squared equals the hypotenuse squared. So we have to fix an angle, so all of this is going to be in reference to that angle theta. And we could use ABCs or X, Y's, R's. I'm going to pretend this is kind of like our coordinate here. So my XY axis. So the distance coming over, I'm just going to call X. The distance going up, I'm going to call that Y. And my hypotenuse, I'm going to call R. Now for any of these ratios, one side to another, what we're going to have is we're going to have 6 different ones. For example, x divided by y, x divided by r. That's the only 2 with x in the numerator. And now we could do it with the y. Y divided by x and y divided by r. And now if we do it with r divided by x and r divided by y. There's no other ratio with 2 sides that we can create. There's 6 different ones. And each one of these is going to correspond to a trig function. There are 6 trig functions that correspond with an angle. So what we have is sine, which is abbreviated SIN, of some angle. So we're using this angle, because if we refer to this angle up here, it's going to change. So sine theta equals y over r. So cosine theta, or cosine, which is abbreviated COS, and then our angle, that's going to equal x over r. And tangent, which is tan, T-A-N, of our angle, is equal to y over x. Then we have cosecant, which is CSC of our angle, is equal to r over y. It's the reciprocal of sine, and we'll talk about that again shortly. Secant, which is SEC of our angle, is equal to r over x, which is really the reciprocal of cosine. And then cotangent, which is COT of our angle, is equal to x over y. So these 6 ratios of 2 sides of a triangle are going to correspond to 6 trig functions. Now once we have 3, the other 3 are just going to be the reciprocals. So you kind of have to know which go with which. So sine theta is going to go with cosecant theta. Cosines, secant, tangent, cotangent. But make sure you have your abbreviations, you know which are which, and don't lose your angle. If you just put TAN equals, you'll lose credit for that because it's a tangent of some angle. We're referring to this central angle right here in standard position. Okay. But again, we're going to have some identities, and so if we talk about identities right now, we already know some, is that cosecant theta equals 1 over sine theta. Secant theta is 1 over cosine theta, and cotangent theta equals 1 over tan theta. So once we find our first three, the other ones are just going to be the reciprocals of that. And we also have, from this, we can come up with more identities, that sine theta is really the reciprocal of cosecant theta. Cosine theta equals the reciprocal of secant theta. And tan theta equals the reciprocal of cotan theta. And we'll use those down the road depending on what information is given. We want to know the ratio of what our sides are with one another. So when you look at the definition that was in your book, it doesn't matter what quadrant our triangle's in. It's going to be our x, our y, our r. Sine is some angle is going to be y over r, and which is that central angle in standard position. Cosine is x over r. Tangent of some angles y over x, where x can't be 0. Cosecant's r over y. It's the reciprocal of some. Secant theta is r over x. It's the reciprocal of cosine. And cotangent theta is x over y, which is the reciprocal of tangent. So now, if we're looking for, all 6 trig functions, so if the terminal side of angle theta in standard position passes through the point 815, that's saying here's 815, x's are 8, we're coming over 8 and up 15. So we're going to have our diagram here, and now we're going to have to find sine of that angle. Notice we don't need to know the angle, but before I can find out what sine is, I need to know what this other side is. So even though we're looking for sine, we can't quite get it yet. We'll have to go 8 squared plus 15 squared equals r squared. So we're using the Pythagorean theorem. Or you could use this one too, the square root of this. But this is going to be 64 plus 225 equals r squared. 289 equals r squared. So if we take the square root of both sides, we get 17 equals r. Now, it really should be plus or minus, because a negative 17 squared is a positive 289. But r, the hypotenuse, this side here, is always going to be positive. If we're solving for x or y, we could have a negative answer depending on what quadrant we're in. If we're in the second quadrant, it's going to be a negative x. If we're in the third quadrant, it's going to be a negative x and a negative y. In the fourth quadrant, we're going to have a negative y. So sine's important depending on which quadrant you're in. But the hypotenuse is always going to be a positive. So now we know sine theta is equal to y over r. And you can almost think of it from this angle. It's the y over the hypotenuse opposite over the adjacent. And we're going to talk about that later on too. But from this angle, you can think of this as opposite hypotenuse. This is adjacent hypotenuse. And this is opposite over adjacent. So sine theta is going to be our y over r. So that's going to be 15 over 17. Cosine theta is going to be x over r. So it's going to be 8 over 17. And tangent theta is going to be y over x. So it's going to be 15 over 8. And once you have those three, the other three are really just the reciprocals of that. But you have to know which go with which trig function. So this is going to be cosecant theta is the reciprocal of sine, so that's 17 over 15. Secant theta is the reciprocal of cosine, so that's 17 over 8. And cotangent theta is the reciprocal of tangent, which is 8 over 15. So there are 6 trig functions referring to the sides of our triangle. Now if we have the point positive 4, negative 3, so I'm going to draw my axis. 4, negative 3, I'm going to go over 4, down 3, and I'm always going to go back to the origin. So this is 4, negative 3. This would be my theta if we were positive, and this if I was going in a negative direction. But again, I want all 6 trig functions. I need this other side. So since I have the 2 legs, here's my 90 degrees. It's going to be 4 squared plus negative 3 squared equals r squared. So here's my x squared plus my y squared equals r squared. 16 plus 9 equals r squared. 25 equals r squared. So 5 equals r, and again it's a positive because it's referring to the hypotenuse. So now sine theta is my y over, so again, y over r, which is negative 3 over 5. Cosine theta is x over r, which is 4 over 5. And tan theta is y over x, which is negative 3 over 4. Once we have those 3, the next 3 are going to be the reciprocals of that. So cosecant is going to be negative 5 over 3. And it doesn't matter if the negative's in the numerator, denominator, or in the middle, as long as there's only one. We have secant theta is going to be 5 over 4. And cotangent theta, the reciprocal of negative 3/4 is negative 4/3. So there are 6 trig functions with our theta in standard position passing through that point 4 and negative 3. So now we just have a bunch more examples, because as the quadrant changes, those signs are going to change. Here's negative 1, negative 1. So now I'm going back negative 1, down negative 1, back to my origin. So negative 1, negative 1. I still need my hypotenuse. So x squared, negative 1 squared, plus y squared, negative 1 squared, equals r squared. 1 plus 1 equals r squared. 2 equals r squared. The square root of 2 equals r. Again, it's positive because it's the hypotenuse. So now sine theta equals y over r, negative 1 over the square root of 2. But we can't leave a square root of 2 in the denominator. But I'm going to leave it there for right now. I'm going to come back and rationalize that when I'm done. So cosine theta is x over r, which is negative 1. My x is negative 1 over the square root of 2. And tangent theta is y over x, which is negative 1 over negative 1, which is positive 1. Now I'm going to leave some room. Cosecant theta, secant theta, and cotan theta. Now, even though I'm not done with this because I have to rationalize that denominator, when you flip this, we're going to get negative square root of 2. Secant's the reciprocal of cosine, so we're going to get negative square root of 2, and 1 over 1 is 1. So it's easier to flip that before I rationalize that denominator. So this is going to be negative square root of 2 over the square root of 4, and the square root of 4 is 2. This is, we're going to multiply by the square root of 2 over the square root of 2. We're really just multiplying by 1. And again, we get negative square root of 2 over the square root of 4, which is 2. But if I go ahead and do the reciprocal of this now, I would have negative 2 over the square root of 2, and I would have to rationalize that and then simplify to get down to this. So when you find the reciprocal, use that main one when you're finding cosecant and secant, and then you won't have to rationalize the denominator over there. So passing through the point negative 2, 7, so I'm going to go back to up 7, remember, back to the origin. It's not a very good triangle. So negative 2, back to positive 7, up 7. My theta in standard position. So I have to find my missing side. So it's going to be x squared plus y squared equals r squared. Negative 2 squared plus 7 squared equals r squared. Positive 4 plus 49 equals r squared. 53 equals r squared. So we get the square root of 53 is equal to r. So this hypotenuse is the square root of 53. Now the square root of 53 is not a nice decimal, so we're going to leave it in there. We're going to find those exact values. So now sine theta is equal to y over r. We're going to keep writing that until the more we rewrite it, the more we're going to remember. But y is 7, and again, if this is our position, you can think of sine is going to be opposite over the hypotenuse, 7 over the square root of 53, and cosine theta is going to be your x over r, or you can think of your adjacent over hypotenuse, negative 2 over the square root of 53. Tangent theta is going to be y over x, which is 7 over negative 2. Now we can go ahead and rationalize these if you want. The square root of 53 over the square root of 53. So 7 square roots of 53 divided by 53, multiplied by the square root of 53 over the square root of 53. We get negative 2 over the square root of 53, negative 2 square roots of 53, I should say, over the square root of 53. And that one's all set for us. So now when we find the cosecant, theta is going to be the reciprocal of sine, but again I'm going to use this one here to flip, so that's going to be the square root of 53 over 7. And if I do that, notice I don't have to rationalize. That's what that would simplify to if we flip this and rationalize. Secant theta, I'm going to use this one, square root of 53 over negative 2, and again it doesn't matter where that negative is, and cotangent theta equals negative 2 over 7. So there are our exact values for 6 trig functions for this angle theta. As theta changes, the sides change, and we'd have a different ratio for each one. 3 square roots of 7. So that one's over 3. So write 3 up square root of 7. Not drawn to scale. but here's our right, here's our theta. So this is going to be 3 square root of 7. And now we have to find our hypotenuse. So this is going to be 3 squared plus the square root of 7 squared equals r squared. 9 plus 7 equals r squared. 16 equals r squared. 4 equals r. So that hypotenuse is 4. It's always a positive. When we start shifting, different, notice here x was negative. Notice here x and y were negative, but r is always going to be positive. So now we're going to find sine theta, which is y over r, square root of 7 over 4. Cosine theta equals x over r. It's going to be 3/4. And tan theta equals y over x, that's square root of 7 over 3. Notice we don't have to rationalize anything. There's no radical in the denominator until we flip. Cosecant theta equals 4 over the square root of 7. So we're going to multiply by the square root of 7 over the square root of 7. So cosecant theta is 4 square roots of 7 over 7. Secant theta is equal to the reciprocal of cosine, so it's going to be 4/3. And cotangent theta, reciprocal of tangent, 3 over the square root of 7. So multiply by the square root of 7 over the square root of 7, and we get 3 square roots of 7 over 7. So those are the exact values of those 6 trig functions. So we have some more examples. Here's a point. Now this one's a little different because here's my point, 0, -5 falls on that y-axis. But as we start, the only difference here now is I'm not going to have my triangle. But if I say x squared plus y squared equals r squared, this is going to be 0 squared plus -5 squared equals r squared. This is 25 equals r squared, so 5 equals r. So again, we have our x, we have our y. We don't have it on a triangle. But sine theta, that theta is going to be in that position, standard position, as we come around. So it's going to be 270 degrees or -90 degrees if we come down. But sine theta equals y over r. Y is -5 over 5 or -1. Cosine theta, x over r, which is 0 over 5, which is 0. Tan theta is equal to y over x, which is -5 divided by 0, which is undefined. We can't have a 0 divisor. So the cosecant theta is the reciprocal of -1, which is -1. Secant theta is equal to the reciprocal of cosine, so it's going to be 5 over 0. It's really r over x, so 5 over 0, which is undefined. And cotan theta is going to be the reciprocal of tangent, which is x over y, which is 0, divided by -5, which is 0. So we have a couple that are undefined because of those 0 divisors. Now the setup of this one is a little different because notice we have an equation here. Instead of giving a point, we have an equation. While we could still find a point on that line, But we could also solve this. If it's negative 12x plus 5y equals 0, then 5y equals 12x, and y equals 12x divided by 5. This is a linear equation where the slope is equal to 12/5 and the y-intercept is 0, 0. So if we were to graph this, we're going to start here at 0, 0. We're going to rise 12. You can see that. Rise 12, run 5. And we would have our line that we're graphing. But because x is positive, we're really going to have our right triangle as we come in here. All right. But what's this distance that you want? You really want your x to equal whatever that divisor is. So we're going to say x is 5, and we want it positive. So we could have had something maybe down in this if x was negative, but since it's x is positive, we're talking about on that positive side. If x is 5, then y equals 12 times 5 divided by 5, which is 12. So when x is 5, y is 12. But we knew that because we had to rise 12 from our slope and run 5. You know, there's our rise 12. Here was our run 5. But again, we're getting that right triangle. We have our x. We have our y. Now we need r, which is going to be 5 squared plus 12 squared equals r squared. 25 plus 144 equals r squared. 169 equals r squared. 13 equals r. So this is going to be 13 is that hypotenuse. So now sine theta equals y 12 over r 13. Again, here's my theta. Now again, if you have a triangle, some of you may remember that French Indian cure for athlete's foot, which is SOHCAHTOA. So right now you're learning y over r, and cosine theta is x over r, and tangent theta is y over x. Now we can get this from here too, is think of this as opposite hypotenuse, adjacent hypotenuse, opposite adjacent. So sine of some angle is the opposite y over the hypotenuse, r. Cosine is your adjacent, x, over your hypotenuse, r. Tangent is opposite, y, over your adjacent, x. So this is just a memory tool to remember those first three. But you also have to remember that cosecant theta is the reciprocal of sine, 13 over 12, and secant theta is the reciprocal of cosine, 13 over 5, and cotan theta is the reciprocal of tan, 5 over 12. So even though we have a line, you know, when we're graphing, we can still find a point. Now we could have gone further. We could have used 10 and 24 and that would have reduced. Y equals x. So m equals 1. Y-intercept is 0, 0. So when we graph, we start at 0, 0. From there, up 1, right 1, up 1, right 1. This is our y equals x line. But we want negative. So we're going to be down in this third quadrant. We want when x is negative, here's our triangle. Now, pick anything you want. We'll say when x is negative 1, since y equals x, then and x is negative 1, then y equals negative 1. So this is x negative 1, y is negative 1, would give me that point. We still have to find the hypotenuse, our r value, negative 1 squared plus negative 1 squared equals r squared. Now you'll notice I'm using parentheses here because if you put it in your calculator without the parentheses, you're going to get a negative 1. But with parentheses, negative 1 times negative 1 is a positive 1. That's 1 plus 1 equals r squared. 2 equals r squared. The square root of 2 equals r. That's our hypotenuse. So we have sine theta is y, that negative 1 over r square root of 2. We have to rationalize this, so this equals negative square root of 2 over 2. Cosine theta equals x, which is negative 1, over the square root of 2. And again, we have to rationalize that, negative square root of 2 over 2. Tan theta is y over x, which is 1, positive. And now the reciprocals. Cosecant theta equals negative square root of 2. Secant theta equals negative square root of 2. Again, I'm reciprocating before I rationalized it, so I don't have to do it again. And cotan theta equals the reciprocal of 1, which is 1. So one more problem like this before we talk about the unit circle. 5x plus 3y equals 0. 3y equals negative 5x. Y equals negative 5x divided by 3. So graph that. Our slope is negative 5/3. Our y-intercept 0, 0. So 0, 0. Down 5, right 3. We're going to have a decreasing line. We want when x is negative, so I'm going to use x is, and I can use anything for x. If I say 1, then y is negative 5/3. Now what I'm going to do is use a multiple of 3, so my y comes out nice. So I'm going to say x is negative 3, then y equals, so if you think what we're doing is, here's negative 3. Now if you wanted to use negative 1, that would be fine. It'd be a smaller triangle, but we'd have a fraction for our y value. So I'm going to use negative 3. Negative 5 times negative 3 is 15. Positive 15 divided by 3 is a positive 5. So that's how I'm coming up with those sides. But you can use anything you want. Here's theta. So now negative 3 equals r squared. 9 plus 25 equals r squared. 34 equals r squared. The square root of 34 equals r. So this is the square root of 34. So once I see a square root in there, I know I'm going to have to rationalize the denominator of some of these. Let's see, sine theta equals y, 5 over r. So I'm going to rationalize that one. That's going to be 5 square roots of 34 over 34. Cosine theta is going to be x, negative 3 over r, square root of 34. Negative 3 square roots of 34 over 34. Tan theta is going to be y, 5 over x, negative 3. I don't have to rationalize that one. The cosecant theta is the reciprocal of sine, so I'm going to flip it here. Square root of 34 over 5. Secant theta is the reciprocal of cosine, so negative square root of 34 over 3. And cotangent theta is the reciprocal of tangent, so negative 3/5. So that gives you a few different examples if you were given a point or given an equation to find the 6 trig functions of some angle. Okay? And again, those 6 trig functions are corresponding to the ratio of the sides of a triangle. There's only 6. Now, with a unit circle, so you're going to see this often. So here's a unit circle. With a unit circle, our equation for a circle is x squared plus y squared equals r squared. So that's why we've been using this with the center at the origin 0, 0, and r is our radius. So that's really our r there. Now, with a unit circle, the radius r equals 1. So what we have is x squared plus y squared equals 1 is our unit circle. But if r equals 1, now remember, sine theta equals y over r, which is going to be y over 1 on a unit circle. And cosine theta is equal to x over r, which is x over 1. So on a unit circle, r equals 1, then x is going to equal cosine theta, and y is going to equal sine theta. So on all these points, as you come around, this point xy on a unit circle is going to be cosine theta, whatever our angle is, sine theta. So if we're looking for the sine of 0 degrees, cosine 0 degrees, tan 0 degrees, cosecant 0 degrees, secant 0 degrees, and cotan 0 degrees, then what we're going to use is our unit circle. 0 degrees corresponds to this point right here. So it's going to be 1, 0 is our point. And remember, this is xy, so this is going to be our cosine. So the x is going to be cosine, our y is going to be sine. So what's the sine of 0 degrees? It's going to be 0. What's the cosine of 0 degrees? It's going to be our x, which is 1. Tangent is going to be our y over x, which is going to be 0 divided by 1, which is 0. Cosecant is going to be the reciprocal 1 over 0 of sine, so that's undefined. It's a reciprocal of cosine. The reciprocal of 1 is 1. And cotangent is going to be the reciprocal of tangent, 1 over 0, which is undefined. If we want to find sine of 90 degrees, cosine of 90 degrees, tangent 90 degrees, cosecant 90 degrees, secant 90 degrees, and cotan 90 degrees. So whereas 90 degrees on our circle, as we go around, it's going to be here. So we're going to use this point now. So it's going to be 0, 1. So again, here's my xy. So sine 90 is y. That's going to be 1. Cosine 90 is going to be 0. Tangent is going to be y over x. So it's going to be 1 over 0, which is undefined. Cosecant is going to be reciprocal of sine, which is 1. Secant is the reciprocal of cosine, 1 over 0, which is undefined. And cotangent is going to be the reciprocal of tangent, which is 0 over 1, which is 0. So no matter which point you're using, as we go around, at most you're going to have is 2 undefineds. So if we want to find 180 degrees, so here's 180 degrees, we're going to use this point. negative 1, 0. So let's do that one. So sine of 180 degrees, cosine of 180 degrees. We have tangent 180 degrees, cosecant 180 degrees, secant 180 degrees, and cotan 180 degrees. Again, the point at 180 degrees is going to be that negative 1 comma 0. So this is xy, or you can think of it as cosine sine. Think of it as alphabetical on that unit circle. So sine 180 is going to be 0. Cosine 180 is going to be negative 1. Tangent is going to be 0 divided by negative 1, which is 0. Cosecant is going to be undefined. Secant is going to be negative 1. And cotangent is going to be undefined. So if theta equals 270 degrees, that one's left to you. But if you were to look in your book, that's where all these values are coming from. So I'm not asking you to memorize these values. If you can draw your unit circle, as you come through, draw that unit circle, and you're going to be able to find the value of all these. So now, and you can do some of these on your calculator, but you have to be careful, with tangent. Tangent 90 is undefined, but if we do the cotangent of 90, that's going to be 1 divided by 90 in your calculator, and it's going to have a problem with that, even though it is the cotangent of 90 is 0, if you were to look. But now you're going to apply these values. How you're going to apply these is we want to evaluate some of these expressions. So anytime it's a quadrantal angle, you're going to use your unit circle, where radius is 1. This is going to be 1, 0. This point up here is 0, 1. This point negative 1, 0. And this point is 0, negative 1. So the cosine of 90, I'm going to cosine, here's my 90. Remember, it's cosine sine. So cosine of 90 is going to be 0. Sine of 90 is going to be 1 minus tangent of 0. Now I'm going to come over here. Tangent is y over x, so that's 0 over 1. So we get 0 minus 0 squared, which is 0. Cosine is 0. Well, now I'm 0. Here's my cosine, is 1, plus secant of 0. Well, that's the reciprocal of cosine, so that's 1. The sine of 90, so I'm going to 90. Cosine sine, sine of 90 is 1. So we get 1 plus 1, which is 2. Sine squared of 90, so that's sine of 90 squared, which is going to be 1, plus cosine of 180. So if we go cosine of 180, here's my cosine, negative 1. And the sine of 270, so here's my 270, here's my sine, cosine sine, it's going to be negative 1. So we get 1 plus 1, which is 2. So that's using our unit circle for those 0 degrees, 90 degrees, 180 degrees, or 270 degrees. If it was 360, that's just a rotation. We're back to 0. It would be a coterminal angle. I hope this helps with section 5.3.